Okay, guys, we're back. We had a question in one of the comments about how to use peer-to-peer for averaging temp sensors between two VAVs to maybe two VAVs are controlling a large room, and you want to use two peer-to-peer between the two VAVs to average the temperatures. So I got this program here. We're already in it. We're doing just that. This little symbol right here means the unit's peer-to-peer. And how we set that up is you come in here and you give it the device instance number of the controller where you're wanting to pull the peer-to-peer from, and the object identifier of the peer-to-peer object that you want pulled. So where do you get that information? Well, this is zone temp. So you come down here to zone temp, click on it, and it tells you right here, object identifier is AI1106. And then the controller I'm pulling that from is 1005. So that's where we got this information here. Controller 1005, 1106. Pulling that in. I'm also doing the same thing back to that controller. So this controller's instance number can be found in network settings. It's 1006. So we're pulling that over to that one. And all we're doing is you can go back and watch the min-max average video to get the logic here on how to do min-max average. But all we're changing is where we're inputting our inputs from, our pass-throughs from pretty much. So instead of another sensor here in the hardware inputs, we're actually using another sensor up here in the network input. So we're networking over a temperature right there. And I wanted to bring in warm cool adjust. That way you could see the changes there. So we got one is the temperature of the hard device here, and two is the network. So one, I can drop the warm cool adjust all the way down to, let's see how far as it'll go. It'll go down to -5 for me. So we should see a change in the warm cool adjust here, drop down to -5. That'll be here once it updates here. We'll give it a second. Nope. Okay. I had the wrong stat. Sorry. So that was the network one that came in is -5. And see, it's represented here as -5. So I guess our hardware one, I'll go +5 on. Up. So now I got a +5 on our positive. Warm, cool, adjust. We should see that change here. There it is. +5. So that gives us an average output of 0, a max of 5, and a min of -5. See where we're going there? The stats are side by side, so we won't see too much of a difference here in your average output. I got 65.2 on one and 66 on the other. And then what we would do here, instead of all these points coming out of this zone temp, we would change it over to this guy. And we could do that right now. Can't do it in commissioning mode. We have to do it in configure mode. But we would come over here to zone temp, use the hyperlink, change the connection to our min max average. And if we want to use the average, we're already set up for that. And keep going through here until we get them all transferred over. And remember, if y'all are used to working in, say, Honeywell, all this is at the bottom is sort of the pass-through to the logic. A lot of people complain that Johnson, you have to connect it twice, but it really is the same as doing a pass-through block in Niagara logic, or Honeywell logic. Change. And that one we don't change because that's the one going to min max. And then our warm cool adjust, it only really goes to 1, so we can change that guy too. So warm cool adjust, if we wanted to take the average, we can come over here and we're going to select this one because that's our warm cool adjust block. And now all we'd have to do is transfer it back to device. You can save it to your computer if you need to. Use our lovely map gateway to transfer this back into our 1620 that we have here in the lab. Go ahead and commission after. I know this went super quick, but if you slow down the video, it's all it is where you're connecting your point from your pass-through block. And like I said, instead of grabbing it from a hardware, you're just going to grab it from a network input. And if you know how to do peer-to-peer, all you got to do is know your instance number of the device where you want to pull the point from, and then the object ID of where you're going to, what point you want. Now the object ID, that gets a little tricky. I'll show you a little hang up on that once we get into commissioning mode. Here our lovely actuator starting to turn, so our program should be downloaded. There it is. So the gotcha on the object ID is in peer-to-peer. I'm gonna go back into configure mode so we can see this. So if I'm doing a new, say I wanted to pull the damper position from the other box. Our damper position is AO2131. So I can come up here and make a new input, call it damper R PO damper 2 key position. Okay. Put it up top. Okay. So if we wanted to do peer-to-peer, we know our object ID of the other one. So see, this is where it gets with people. They would just put in 2131. Well, that's not all. You actually have to drop this down and choose the value. What was it? AO? I'm probably wrong. So let's see. I'll look at it again. Yeah, AO 2131. So if we have AO 2131, boom, we should have now the damper position. And as soon as you start putting stuff in this, as soon as you change this from disabled to anything else, you're going to get that little symbol right here showing peer-to-peer. You can also output peer-to-peer to other controllers, but I tend to like to pull the point in instead of rather than blast it out. You can do both, but I like to use the inputs. Let me know what the difference is if you like to use the blast out. But we can actually transfer this to device, and we'll see that damper position of the other one. Now this only works obviously if it's the same program loaded in. You got to have the same object IDs, but if you use the system tree, select tree, you're going to get the same object IDs every time. If you add a point, you're not going to get that same object ID every time. So just know that. You might have to go into the CAF file of the other controller to get that peer-to-peer object ID. Load this real quick just to show you that we're pulling in the damper position of that other controller, which should be 100% open. And it doesn't have to be the same controller type. It could be an air handler. So you can have a unitary controller that you're pulling this point from. It could be a totally different controller. Actually, I have two controllers. I'm hooked into a 1620 right now, and I'm pulling points from the 1630. I mean, they're both VAV controllers, but in the BACnet world, it does not matter. There's my damper 2 position 100%. As you see, it's not my damper 1 position, but my damper 2 position is 100%. All right, so I hope you understand how peer-to-peer works and how you can min-max average from a peer-to-peer point. Let me know in the comments below if you need any help with this. Thanks.